In this video, we're going to do the last two questions in your handout for percent composition. Make sure you try them yourself first and then check over your work using this video lesson or simply the answers from the slides. So our question here is determine the percent composition of glucose. And that basically means find the mass percent of all the elements in the compound. So in a question like this, where you don't have any mass data, you need to use your molar mass. So that's really my first step, is to find the molar mass of the entire compound, which is the molar mass of C6H12O6. And so from periodic table data, that's 6 times 12.01, which is the carbon molar mass. So that's 72.06 grams per mole, plus 12 times 1.01, which is a molar mass of hydrogen, but there's 12 of them in there. So 12.12 grams per mole, plus the molar mass of oxygen times 6. So 6 times 16, 96.00 grams per mole. Oops, let's make that consistent. And the reason that I'm keeping two decimal places is because that's what there is in the periodic table for our molar masses. And that's going to be equal to, so 96 plus 72.06 plus 12.12. And I get 180.18 grams per mole. So this is acting like the total mass of my compound, because again, it doesn't matter the size of the sample. Your percentage composition should always be the same for glucose. So that's our first step. Our second step is going to be to find the mass percent of, well, let's do carbon first. So mass percent of carbon, whoops, let's write that properly. Mass percent of carbon is equal to the molar mass of carbon times 6. So 6 times the molar mass of carbon, because there's 6 carbons, over the total molar mass of the glucose, which is C6H12O6 times 100%. And so that'll be 72.06 grams per mole divided by the 180.18 grams per mole. Cancel those out, times 100%. So we get 72.06 divided by that 180 times 100%. And I get 39.99. It keeps going. 999%, or approximately, if we want to keep it to 4 sig figs, we get 40.00%. And so that's our mass percent of carbon. We now have to do the same process, but for the other elements. So let's do the mass percent of hydrogen is equal to 12 times the molar mass of hydrogen over our molar mass of our compound of glucose, which is C6H12O6, times 100%. And that will give us 12.12 grams per mole over the 180.18 grams per mole. Cross those out because they're the same unit, top and bottom, then times 100%. And we get 12.12, so 12.12 divided by 180.18 times 100. And we get 6.7266066727%, or approximately, to keep it at 4 sig figs, 6.727%. And now we'll finish up by doing the mass percent of oxygen. I'm not going to write out all the steps like I did before, but mass percent of oxygen is going to be equal to the 96.00 grams per mole divided by 180.18 grams per mole. Cross those out, times 100%. So we have 96 divided by 180.18 times 100. And we get 53.005328%, or approximately to 4 sig figs, 53.28%. And that's my mass percent of oxygen, mass percent of hydrogen, mass percent of carbon, which make up the percent composition of glucose. But just to make sure I'm right, I'm going to add up all the data I had. So 40 plus 53.28 plus 6.72, and I get 100%. So when I check my work, it all adds up to 100%, which means that I'm on the right path. You could also check by going to the slide deck here. And if you go to the slide deck, you'll see the sample problem with the glucose over here. We got 51.41, 6.490, and then 42.10, which is roughly what we would expect over here. Let's just make sure I did that right. So if our answers make sense, this was for sucrose. We wanted a glucose over here. This is the correct one. I looked at the wrong one, so glucose right here. And it looks like we have 46.7, 53.28. And we do want to maintain that to 4 sig figs. So I believe on here we have the correct 6.727. That's right, that's correct. And over here we had 6.7. That's right. So all the sig figs work out, percentages work out, everything adds up. We were correct in that case. So that was for that example where we didn't have mass data, but we had the molar mass that we could figure out. Now, in some cases, again, you don't have a formula. And so because you don't have a formula, you have to use mass data that's provided. So we have an 11.5 gram sample of a liquid compound that has 6 grams of carbon, 1.51 grams of hydrogen, and the remaining is oxygen. Find the percentage composition of this compound. That basically means find the mass percent of all the elements in the compound. Let's write down the information we know. We know the mass of the compound, even though we don't have the formula, is given to us as 11.5 grams. We know the mass of carbon in the compound is 6.00 grams. We know the mass of hydrogen in the compound is 1.51 grams. So I wrote it the information, and there's one more thing I have to figure out, and I'll call this step 2 here. I need to figure out the mass of oxygen. The mass of oxygen, you'll notice it's not given to you directly, but you could figure out from the information that's provided here. You can simply do your 11.5 grams minus the masses of the other elements, because what's left over must be oxygen. So 6.00 grams plus 1.51 grams. So 11.5 minus 6 minus 1.51. And we get 3.99 grams. Now, normally you would round to the proper number of sig figs, but since this is one of my intermediate steps, my steps in between, I'm just going to leave it because I don't want to round too much and be off in my percentages. So I'll leave it as is right now, and I'll just round at the end for sig figs if I need to. So we have I just want to make sure that's right, 11.5 minus 6 minus 1.51. 3.99 grams of oxygen. Perfect. So now our step 3 is to find the mass percent of any of the elements. Let's just do carbon first. It's going to be the mass of carbon over the mass of the compound times 100%. And so we'll get 6.00 grams over 11.5 grams times 100%. And we'll get 6 divided by 11.5 times 100, 52.1739130.4%, or approximately to 3 sig figs, 52.2%. We can do the same thing for the mass percent of the other elements. So let's do mass percent of hydrogen is equal to the mass of hydrogen in the compound divided by the mass of the compound total times 100%, which is the 1.51 grams over the mass of the compound, which is 11.5 grams, times 100%. So let's go ahead and do that. 1.51 divided by 11.5 times 100. And I get 13.1304347.8%, or to 3 sig figs, let's do 13.1% for hydrogen. And then lastly, for oxygen, so mass percent of oxygen is equal to the mass of oxygen in the compound divided by the mass of the compound times 100%. And so that's going to be 3.99 grams over 11.5 grams. Cancel out the grams times 100%. And we get 3.99 divided by 11.5 times 100. 34.69565217%, or approximately 3 sig figs, 34.7%. And to double check, I'm just going to see that these all add up to 100. So that plus 13.1 plus 52.2, we get about 99.995. So based on my rounding, I'm a little bit off, but I'm still pretty close to 100. So we know that I found the correct percent composition. In other words, the mass percent of all the elements in that compound. And you can go back and double check in your slide deck to make sure that you're on the right track. So this was our question over here. So about we had 52.2%, 13.1%, 35%. So we're on the right track with that. This is following the significant figures rules here that I mentioned earlier. The one in the slide did not quite follow that. So make sure you take a look at this video. If you were thrown off by significant figures and you looked at the slide, this will clarify that for you. In the slide deck, there also is one more practice problem that you can attempt over here. And you can just click on the presentation and then just press any key like spacebar to remove the red and then allow you to see the answer key. So there's more practice for you to attempt when you're doing percent composition and mass percent. It is important you understand this concept because it'll be directly related to what we're doing next, which is the empirical and the molecular formula lesson.